Okay, I'm back, and you can see that I have on the floor a set of meter sticks. And so over here is going to be my starting point. And then the cart is going to roll to zero point 0.5 meters is right here. And then 1 meter is right here. And then 1.5 meters is here, and then 2 meters, and then 2.5 meters. And so at this point it's going off the screen, but it continues to 3 meters. So if you count that up, that's going to be our 6 different places. And so when the cart reaches each of those distances, I'm going to say mark. So I'll start the car, and when you see the cart begin to move, you're going to start timing it with your stopwatch. And then when I say the first mark, that means that it has gotten to 0.5 meters. Okay, then you're going to record that amount of time on the chart. Then you're going to rewind the video and start it over again, and wait until I say the second mark, which means it's now at 1 meter. So you're going to time that amount of time. Then you're going to rewind the video, start it over again, and you're going to wait until I say mark the third time, and so forth. Okay? So unfortunately, it's going to take you a while to do this. You're going to have to rewind the tape several times in order to get all of these different times. But you want to know the total amount of time that it's taking to get to each of these different marks on the meter stick. Okay, so you ready? Okay. Mark, 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 mark. Okay, so did you get that? I hope you did. So now you know that your distances were at 0.5, 1, 1.5, 2, 2.5, and 3. So those would be your 6 distances, and then if you have timed it, you should now have 6 different times that you have recorded in that first yellow and blue box in your lab write-up. Then it says to plot that data. So you're going to use the computer to actually make a graph of time going sideways and then distance going up and down. And if the computer can do this, so I encourage you to go to, if you don't know how to graph using Microsoft Excel, then go to that Word document on Canvas, Modules, Classroom Materials, and then it will say Graphing with Microsoft Excel. So if you'll use that document, it's going to tell you step by step how to graph using Microsoft Excel. So you're going to make a graph. You're going to then answer the question, is the graph straight or is the graph curving? And then what does this say about the motion of the car? So you're going to answer that question. You're going to find the slope of that graph using Microsoft Excel. So you will have to go to Insert, and then do the scatter plot, then do a right click on one of the data points, and then select the linear curve, and then scroll down to where it says add trend line, and then you're going to go down to put equation on the chart, and then from that you can find the slope of that graph. So all of this is in that document entitled How to Graph Using Microsoft Excel. Okay, now we're going to go down to part 2, finding the acceleration of a ball down a ramp. Now we're going to modify the lab, okay? So you are not going to fill in the chart that is underneath that graph. So instead, what I want you to do is to make a ramp, put a ball at the top of the ramp, let the ball roll down the ramp, and I just want you to describe in words what is that ball doing. So how would you describe the motion of the ball as it rolls down the ramp? Okay, and then I'd also like for you to be able to answer the question why. So why is the ball doing what it does? So you don't need to fill out those boxes, and you don't need to make any graphs for this one. So this is just going to be purely observing a ball as it rolls down the ramp, and then explaining the motion of it, and then explaining why does it have that motion. Okay, then you can do the post-lab questions. So under your post-lab questions, what did you learn in the lab? You can fill that out. Which part of the lab was the most useful? So you can do that. Which part of the lab was the least useful? What were some sources of error in doing your experiment? And then how could the lab have been changed to get more accurate results? Okay, number 6 is to explain what causes something to accelerate. Question number 7. Oh, I did want you to do this one. So I wanted you also to change the angle of your ramp and then repeat the experiment. And notice what effect does it have when you increase the ramp. And so then you can answer question number 7. Why did changing the angle of the ramp change the acceleration? Then question number 8, if the acceleration is in the same direction as the speed, what happens to the speed? Okay, question number 9 is what happens to the speed of an object if it's not accelerating? So if the acceleration is 0, what happens to the speed of an object? Okay, question number 10 is what happens to the speed of an object if the acceleration is in the opposite direction? So let's say that the speed of an object is going forward, but the acceleration is going backwards. What would that do to the speed of the object? Question number 11 is a math problem. A ball moves 1.5 meters in 3 seconds. What's its average speed? And then number 12 is using your answer from question 11, use that to answer question 12. And then finally, question 13, answer that question. And question 14, you should be able to answer that one. So there you go. So that is this lab. So you're going to do everything on the computer, and then you're going to email it to me. So hope you enjoyed that, and I'll see you in class next time. Bye.